start recording. Okay, so I would like to go through some work with you guys, or a demonstration of how to use a couple different symbology tools. That's the purpose of this. And some of you, this you may have seen before, but perhaps it'll be new for some of you. And so I'm going to do this work. I'm going to make a new folder. I'm in my E drive where I do work for this class. I'm going to make a new folder here called in class. If I could spell. And if you guys have questions, please just chime in or use the chat. And so this is where I'm going to do my work in this sort of in-class symbology guy. So, oh, it looks like I was only sharing. Let me stop sharing and start sharing again. Sorry, I'm having some sharing issues here. Screen 2 is what I want. Share screen 2. So I'm going to create a new map for this guy, and I'm going to put it in that folder that I just created. And again, you'll see, so I just created that folder called in-class symbology. So here we go. So that's where I want this guy to be. And I'm going to call this symbology demo. And bringing up a brand new map. And I'm going to add some data to this. I'm going to start using just a raster that I happen to have, which is a digital elevation model. And I can share this DEM with you guys, but if you want. But I'm just gonna, it's from California. It was created via LiDAR. And it should be adding in here. There we go. And so what you're seeing here is a digital elevation model. And I'll zoom out so you can get a sense about where this is located. So it's in the, the Central Coast Range, just north of Santa Barbara area. So that's what's shown right here. And if I click on, and you'll see it's got different colors, right? And if I don't know how well you guys can see this, but it says the values from 788 to 272. So if I click someplace, this says it's at 535. That may be kind of tiny to see on your screen. If I click in this sort of white place over here, that's 757. If I click in one of these dark places down here, that's 338. Those values are elevation values, right? So if it's 338, that means it's 338 meters above sea level. And if it's, click over here, 654, it's 654 meters above sea level. And those values are represented by these different colors. So low values are black in this case, and high values, high elevations are white. I can change that if I want to make it a little bit more interesting color scheme. I'm going to choose something like this. All right. Now it's important to note that the data haven't changed, right? If I click here, it's 746. It was 746 whether or not this had this color scheme or if it had the black and white color scheme, right? The data values themselves haven't changed. There are ways to visualize this that are more interesting than what we're seeing currently, or more visually sort of appealing than what we're currently seeing. Although hopefully you guys now get the idea that these dark green places are lower elevations and these sort of white or pink places are higher elevation. But a way to sort of see this a little bit more clearly is to use a hillshade tool. So in the geoprocessing guy, if you click up here in hillshade, there's going to be this hillshade tool. And if you click the little question mark, it'll tell you a little bit about this guy. What does it do? So it creates a shaded relief from a surface raster by considering the illumination source angle and shadows. And what that basically means is it's going to create a new representation of this data set that is what it would look like if the sun was shining on it at a given azimuth and altitude. Basically the position, this is controlling the position of the sun in the sky. Okay. And so this is the input, which is our raster, our digital elevation model. And then I'm just going to leave this default sort of output name, which is the hill shade of the input LiDAR guide. And then the azimuth and the altitude, which are basically the sun position in the sky. And this will be a lot more clear in a second once I actually run this thing, I hope. I'm going to leave those as default. And I'm just going to run this tool. Again, this is the hill shade tool. Oh, and interesting, right? So this now looks quite a bit different than this one, right? This looks quite a bit different from this one. So if I zoom in here, what I'm starting, again, this is a hill shade relief. So this is what this raster would look like if the sun was shining on it and you were sort of, looking at this landscape, right? So if you're basically flying over this from an airplane, it would look a lot more like this. It wouldn't look so much like this. Okay. And so we see cool stuff, right? Oh, there's this looks like a road has been carved out into the mountains. And we see these sort of drainage divides and other things. And we see these dendritic, riparian areas. And if you flick back and forth, you can kind of see those patterns, at least some of those patterns, right? But it's a lot easier to see in the hill shade. But the hill shade, as shown, it's not giving us information about elevation, right? Although we can we can look and this looks like this is, I don't know if you can see my cursor, but this looks like a stream bed or something. So that's probably lower than, this area up here. But I think maybe a more helpful way to show this, and it's not really a trick, it's just sort of a visualization or a symbology way to do this, is to take your hill shade that you've created and click on its appearance and then change its transparency, right? Change its level of transparency. And by doing that, now you kind of get the best of both worlds, right? You're able to see, if you know about the color scheme over here, that these green areas are lower in the landscape. Let me turn off these bottom guys. And these, white areas are higher in the landscape, and you got these sort of moderate colors in between. And again, you can change this transparency to whatever you want it to be, right? You can be, very transparent, or you can be, not very transparent at all. So someplace kind of in the middle, I think, is a real helpful and intuitive way, I find, for looking at landscapes and depicting this sort of, three-dimensional sense of the place in a way that is building only from, right, the original digital elevation model that you started out with. So that's one kind of helpful, way of visualizing elevation data that I think can be hopefully useful for you guys in some of the things that you're trying to show. So that was one thing I wanted to share. I don't know if there's any questions on that, but that is sort of the first sort of set of information I did want to share for you guys about, visualizing digital elevation models with this idea of semi-transparent hill shades over top of the DEM, the colorized DEM. Okay, so we are going to, I'm going to make a new map. And in this one, I want to add some data that I'm going to download from the Hawaii GIS page. I'll swing this over. And I want to download some agricultural data, because we're going to do a comparison of change over time. And again, I saw this in some of your early maps. You guys were trying to show how things change over time, and you can use some additional tools to maybe help show this. So we're gonna look at the 2015 and 2020 data. So first is the 2015 data. So I'm going to download this guy and I'm going to put it in this location here. Again, if there's any questions, please let me know. So there's the 2015 data, and then I'm going to download the 2020 data. This is again from the Hawaii State GIS page. So I'm going to save that information. I got to unzip those guys. So I'm going to right click and extract. So I'm extracting the 2015 guys, and then I'm going to create, and then I'm going to extract the 2020 guys. Okay, so I've got my data. Beautiful. And now I want to go back to my ArcMap guy and add those data. So I'm going to go to this PC to my correct location in class symbology. Oh, I'm not seeing anything. If I refresh this guy, right, refresh this guy, then these new ones that I grabbed will pop up. So in the 2015 one, it's provided is both the shapefile, but also this layer guy. And the layer guy is nice because it gives you, already set up the symbology. So we're gonna open that guy up. Looks like Avalon's coming in, so we're gonna let her in. And so what we can see here, this is for the entirety of the state, and the symbology's already come in. It's by crop category. And if we look at Honolulu, we can see all this nice stuff, right? So this purple is diversified crops, and the lighter green is pasture, and so on. Okay, so this is, and this guy has it for all the major Hawaiian islands, the 2015. So I want to now add in the 2020 data. And so I'm navigating to this, and now I don't have a layer guy associated with this one. All I have is a shapefile. So that's what I've got. So that's what I'm going to add in. And oh, this is interesting. So everything is pink, right? To start, everything is pink. Let me turn off this 2015 guy. And there's no data for Maui Nui. And that's because the Department of Agriculture hasn't released the full 2020 data set yet. But we've got data for Big Island, we've got data for Oahu. But right now it's all pink, it's all the same. But if I want it to be comparable to what we see for the 2015, I can do that. So if I go to symbology, and then I believe it's import symbology, that will open up this sort of tool over here. So the input layer is the Ag Use 2020. The symbology layer I want to match is this 2015 guy. And it's the value field, the source field. It's the crop category, and the target field is the crops, because this is basically the crop information for these guys. Maintain ranges, that should be fine. So basically what I'm trying to do is I'm trying to make this pink one, appear like what the 2015 looks like. And so to do that, I'm saying the 2021, I want it to look like this 2015 one, and I want to use this crop category as the source field, and the target field, the crops 2020. And if we were to look at the attribute tables of these guys, we can see crop category, commercial forestry, whatever else. That's what's shown up here in the source field. And if I did it for this guy, it's in this one, it's called crops 2020, diversified crop, and so on. So that's where those guys are coming from. And then I say run for this tool, and then beautifully, now that my land use 2020 now has the same kind of symbology as what the 2015 one had. Okay, hopefully that's, and we're about to get into some of the more interesting things, but that's kind of setting it up so far. Now, if the 2020 and the 2015, I'm going to turn 2020 off, back and on, right? They're not exactly the same, right? There's some differences here. If I zoom in on this area, right, I'm showing the 2015 right now, and then here's the 2020, right? So it looks like there's been some expansion in 2020. But expansion is maybe not the only thing that's happened. There may have also been some reduction. There may have been some reduction of areas. So this is the 2020, and then this is the 2015, right? So it looks like some places are no longer cropped. So we've had interesting things. We've had places that have been, are newly cropped areas, and then we've had places which used to be cropped in 2015 and are no longer cropped in 2020. And so if we want to show that change, we want to think about how to do this. And one way to do this is to use some of these different geoprocessing tools at our at our disposal. And the one that I am interested in using for you guys is coming from this sort of overlay tool set. So there's a lot of different tools, and we're going to talk more about this next week. There's hundreds of tools in Arc Pro. And some of these tools do things like intersect, right? Where I've got two different features, a blue and a yellow, and I run the tool, and the only thing that's left of the output of the tool is the places where there's an intersection between these guys. Okay, so that's a tool to use. There's another tool, and which is we're actually going to run, which is the erase tool, where you've got your input layer, and then you got your additional sort of data sets, which is called the erase feature. And then what's left is things which were in the input but were not included in the output. Things which were in the input but not included in the output. And so we're going to use this erase guy to create some polygons, which are polygons which have changed from 2015 to 2020. So we're going to use this erase tool to do this. So I've got my data sets here. Let me scroll this guy over a little bit so we can see. And I want to use this erase tool. So it's going to overlap the input features with the erase features, and only those portions of the input features that are not included in the erase guys get copied to the output. And hopefully this will make sense in just a little bit here. So the input features we're going to start with are the 2015 data. Okay, the erase features are going to be the 2020 guys. Okay, and then we're going to run this. We're going to run this tool. Actually, before I do that, I only want to do this for Oahu. So I'm going to take a break from that geoprocessing guy. I only want to do this for Oahu. I don't want to do it for the entirety of the state, because there's this disparity between 2020 only is not including Maui Nui, but 2015 is including Maui Nui. So I only want to do this for Oahu. So first thing I need to do is take a moment here and just select only Oahu data. And then I can just right click on this guy, and then I can say data and export features, and great. So this guy, and I'm going to call this Oahu 2020. And it looks like that hopefully worked, because if I zoom out, I only see data for Oahu. So that's all I've got. So I've got the 2020 Oahu, great. Minimize this. And then I want to do the same thing for the 2015 data. So map, select. So again, just the 2015 data are being selected right now. Right click on here, go to data, and then export features. And I'm going to call this Oahu 2015. Great. Okay, so now I've got Oahu 2015, and I got Oahu 2020. So for this erase function I want to do, which is going to show me the sort of the difference, the input I want is Oahu 2015, and the erase features are Oahu 2020. And I'm just going to call this Oahu. And I'm going to run this guy. And I'm going to turn everything off except this. So this erase feature, right? What is this? What this is showing me are, parcels, right? These are parcels that, so let's focus on this purple one, for example, this purple parcel. If I look at this in 2015, it's there, right? If I look at this in 2020, it's not there. Okay, so the erase function that I just did is allowing me to see parcels which were present in 2015, but absent in 2020. And that's what this guy is shown right here. Okay, that's what these guys are. Now, if I want to, but I want to symbolize this somehow on a map, right? And so one way to do that is to change the symbology of this guy. So if I go to symbology, I've got these different types of, so there are all these different, colors here, and that's fine, that's great. But what I want to do is I want to change the symbology to make this like a kind of a transparent thing, kind of like what we just did for the digital elevation model. I want to, what do I want to do? I want to format all the symbols. And I want to do it in such a way where I add this is this sort of simple hatch, right? This sort of simple hatch. I can make him, with orchard or nursery, or I can click on these different guys. But what I want to do is I want to do this, 10% simple hatch. And then I'm gonna close this guy. And by doing that, what we've now allowed us to sort of see are, crops which were present in 2015 but are no longer present in 2020. I hope that makes sense, right? So what we've done with this erase feature and this sort of manipulation and sort of overlaying it, we've allowed us to make a map which is going to show places which were cropped in 2015 and are no longer cropped in 2020. We could do a very similar thing where if we sort of, swapped, if we replace these guys, if we said, the input is 2020 and then the output is 2015, those would be sort of newly cropped areas. And we could symbolize those with some other kind of, symbology here to sort of, make those, jump out to your eye. And again, we could change how this is being depicted. But what I just wanted to illustrate this, that what we're seeing here, what this allows us to see on a single map, and not a map, not two paired map that we have to like look back and forth and try as hard as we can to sort of see these small little changes. It allows us to sort of see in a single map places which are no longer present. And this is because of development pressure or other things or such. So that's, again, and you could use this erase tool to do a similar thing if you want to see new cropped areas, right? Because there has been expansion of agriculture on Oahu in some areas. There's been loss in some areas as well. And then you could symbolize the expansion guys in sort of a different way. All right, so that sort of concludes my symbology presentation. If there's any questions on any of that, I'm more than happy to discuss. Hopefully that's useful for you guys as you think about how to indicate change. And you can, again, do that on a single map if you use symbology appropriately. So I'll go ahead and stop the recording now.